All right, ladies and gentlemen, today we're going to start talking about units of measurements. Units of measurements. When we have a measurement, we have a number that is followed by a unit. A number that is followed by a unit. The number is as precise as the measuring tool that is used. So depending on what you're measuring and what you're measuring with tells you the precision. For instance, let's say I have a graduated cylinder. Okay? Will all graduated cylinders have the same precision? Okay? What does it depend on? Yeah. The size of the cylinder, right? So, if I have a 100 milliliter graduated cylinder, and if you look at this 100 milliliter graduated cylinder, the increments in between them are at the ones. Now, if I get out a different graduated cylinder, here is a 10 milliliter graduated cylinder. So the increments in between that is 0.1. So this is a little bit more precise than my 100 milliliter. But if I have a huge volume, okay, not a huge volume, if I have 30 milliliters of something and I want to measure it out, I'm probably not going to use a 10 milliliter graduated cylinder. So the precision is based on the instrument. The use of SI units is the metric system. The metric system. Length. Okay. Mass. Volume. Time. Temperature. Now, what is the metric for length? What's the metric? Yeah, let's see. Connor. Meter. Right? The meter. What is the base unit for mass in the metric system? Tyler? Gram. Okay. We'll use gram, but if we're measuring a bigger substance, like if we were measuring ourselves, okay, if I would be measuring my mass, I would probably use what? Kilograms, okay? Kilograms. Volume in the metric system. What do you think? Volume in the metric system. Come on, folks. We got more than 2 people in here, right? All right, Andrew. Liters. Okay. What about time? That should be an easy one. Time in the metric system. Yeah, Luke. Go even smaller. Seconds. There you go. Seconds. And finally, temperature. Metric system. Metric system temperature, Jacob. Celsius. There you go. Degrees Celsius. Now notice, there's a Kelvin there also. There's a Kelvin there also. We'll talk a little bit later about the differences between Celsius and Kelvin, and you will do some conversions. Now, the main advantage with the Kelvin scale is that there are no negative numbers. All right, there are no negative numbers, so that is an advantage some instances. Now let's compare mass and weight. Mass and weight. The amount of matter in grams measured with a balance. That is the mass. Weight is the force exerted by the mass. Weight is only present when we have gravity. Okay. We measure weight in pounds, and we have a scale. A scale will measure our weight. So the picture that I have right here, this is an astronaut. He's somewhere up in space. He's experiencing what we call weightlessness. Okay, weightlessness. What does that mean? What would you think something that is weightless means? Yeah. Well, no weight. Yeah, why does that astronaut have no weight? Why doesn't he have any weight? What do you think? Brett, why doesn't he have any weight? We don't have any gravity there, right? No gravity. So if we have no gravity, we have no weight. Does he still have mass? Absolutely. So is mass the same as weight? No. Okay, so no. Mass is not the same as what weight is. Oh, I don't want to hear that. Now, which of these tools would you use to measure temperature? What are you going to measure temperature with here? Jasmine, what do you think? A thermometer. What about the volume? What about the volume, Chase? I could use a graduated cylinder right here. Could I use a measuring cup? Yeah, I could use a measuring cup. Now, one thing I always want to make sure I tell folks, what do you think it's better to use when I'm measuring a volume? Is it better to use this beaker, or would it be better to use the graduated cylinder? What do you suppose is going to be more accurate? What do you think, Allie? Absolutely. The graduated cylinder is more accurate. Okay? These markings on the beaker give you an estimation at best. I always tell folks that because in chemistry, a lot of folks want to use these to measure volumes. I say, okay, take that volume right there and measure it. And they'll read the volume. That's 42 milliliters. Okay? And then they'll put it in the graduated cylinder, and they'll realize that they're about 5 milliliters off, at least. Okay? So more accurate would be the graduated cylinder. Obviously, Abdullah, what are we going to use to measure the time here? Which of these instruments? The stopwatch up there. And finally, the weight. The weight, what do you think, Anthony? The scale right here. Okay. Now, just a learning check. A bag of tomatoes is 4.6 kilograms. That is mass. A person is 2 meters tall. That is a length. A medication contains 0.50 grams of aspirin. That's a mass. It's in grams, right? A bottle contains 1.5 liters of water. That is a volume. Okay, we've already dealt with units. Okay, once again, we stated that length is what? Meters. Volume is what? Okay, volume is liters. Weight, okay? Well, that would be mass. Okay, with the weight, let's go back to the English method, the pounds, and finally the temperature. Celsius or Kelvin, we said we could see. Now, metric prefixes. I'm sure that we've all dealt with the metric system at one time or another, whether it be in a science class, whether it be in a math class. Okay? I was always taught King Henry died by drinking chocolate milk. Okay, I don't know what little memory device you folks were taught, but that's always the way that I was taught. You know, kilo, centi. Okay. Milli. These are some that we are familiar with, or should be familiar with. Kilo means 1,000 of that unit. 1 kilometer is 1,000 meters. Centi is 1/100th of that unit. 1 meter is equal to 100 centimeters. $1 is equal to 100 cents. Milli is 1/1000th. So 1 liter is equal to 1,000 milliliters. Now, like I said, we're probably familiar with those parts of the metric system. However, we're going to take this in here a little bit farther. Okay? What I would like for you folks to do is I would like for you to copy this chart in your notes. I'm going to give you time to do it here. So copy that down, but I want you to include, they don't have one in here, but I want you to include it right here. Okay, let me do it in blue so you can see it better. Right here, in between deca and deci is base. And base is 10 to the 0. So go ahead and get that copied into your notes. Now this scale of metric prefixes goes above and below what you are normally dealing with. Usually kilo is the highest, okay? But, you know, if you start to look, and a lot of these higher ones, where we're most common with is with our computers. Have we heard of a gigabyte? What about a new one is a terabyte? Have you heard of terabytes? Probably. All right. Now, when we get even smaller, micro is usually the smallest, but now nano, pico, okay, micro, nano, pico, those typically where we see those used is in biology. If I see something like a very, very small electron microscope, okay, they can go as to so small with the individual organelles. So you might see a picture of a mitochondria. that was taken by electron microscope, and usually I would say that they're going to deal with somewhere either micro, nano, or pico. Now the big thing is that I want you to understand is these numbers, okay, these numbers. If you remember, King Henry died by drinking chocolate milk. Okay, how do you go from meter to kilometer? You move the decimal point, what and how many? What way, how many places? We're going from meter to kilometer. We're moving it to the left, how many jumps? 3. Now if you look right here, to get from base to kilo, look, to get from base is 0, kilo is 10 to the 3. So how many jumps? 3, which way? To the left, right? So as I'm going up that scale, I'm moving it to the left. As I'm going down the scale, I'm moving it to the right. So how many would I jump the decimal to get from centi to micro? From centi to micro. Well, centi is 2, right? What's micro? 6. So how many jumps from 2 to 6? 4 jumps. What way are you going to jump it? To the right. So that's how you read the chart. If I've got kilo and I want to go to tera, okay? Kilo to tera, how many jumps? Which direction? 9 jumps to the left. See how I'm reading my scale there? We okay with that? With thumbs up here? Can we read that scale and convert? Because you're going to have to do that here, folks. You're going to have to do that. So make sure you know where this specific chart is. Now these, not really that important. I just put in there. Those are some metric conversions. Okay. Here's a learning check. 1,000 meters is equal to 1 what? A, B, or C? B, a kilometer, right? Whoa, go back. Okay. 0.001 grams is equal to what? A milligram, right? Okay. 0.1 liter is equal to 1 deciliter. It's only one jump, right? 0.01 meters is equal to a centimeter. Now, here's another version that I told you. Here's another version that I told you. When we're dealing with some very, very small figures. This one here, we're measuring the distance between the nucleus of a hydrogen and oxygen of a water molecule. So that's a pretty small measurement. Well, it's 9.4 times 10 to the 11th meters. It's 9.4 times 10 to the 9th centimeters, or it's equal to 0.094 nanometers. So once again, just one of those small measurements, and that is the length. Those are just conversions, I'm sure. If you were going to measure your height, what would you use? What would you use to measure your height? Yeah. I would use meters, okay? I would use meters. What about your mass? We've already talked about that. If we're going to measure our mass, we would use... Brandon, what do you think? Kilograms for our mass, okay? The distance between two cities. Distance between two cities. Nolan, what would you use? Kilometers, good. The width of an artery. The width of an artery. What do you think? I would go with millimeters also. Millimeters. Now let's talk about some conversion factors. Let's talk about some conversion factors. Fractions in which the numerator and the denominator are equal, quantities expressed in different units. So if I look at this, the example is 1 inch is equal to 2.54 centimeters. So I can use those values to convert from inches to centimeters. Because they are what we call equalities. And if you look, when I put them into a fraction, 1 inch over 2.54 centimeters. Or if I need to convert it a different way, the other way, 2.54 centimeters over 1 inch. But the key to this is that both of those are equal. Both of those are equal. So, if we were going to write a conversion factor for this right here, I could put 1 liter over 1,000 milliliters, because they're equal, aren't they? What about hours and minutes? 1 hour is equal to 60 minutes. There's my conversion factor. What about meters and kilometer? 1,000 meters is 1 kilometer. Now, how are we going to use this? Okay, how are we going to use this? Well, we use that conversion factor. How many minutes are in 2.5 hours? Well, how I do this, folks, and it's a little bit different. I set up what I call a conversion box, and I have that conversion box in blue here. And in my conversion box, what do I put in the numerator? What do I put in the denominator? Depends on what I want to cancel. In this case, I'm given 2.5 hours, and I'm trying to convert hours into minutes, so I want hours to cancel. So I put hours in the denominator, I put minutes in the numerator, and when I do my calculations, I take 2.5, I multiply it by 60, and then I divide it by 1. Well, dividing anything by 1 is just itself, so all I need to do is take that value and multiply it by 60. So 2.5 times 60 gives me 150, and whatever unit I have left is the actual unit that I use. So that's a real nice, easy one. I've converted that from hours to minutes. Here's a sample problem. Go ahead and do that. Do that problem in your notes. See if you can calculate it. Is really $1, right? So my conversion box I'm going to set up, I want dollars to cancel, so I put $1 on the bottom. $1 has how many quarters? 4 quarters. My dollars cancel, my dollars cancel. So if I take 2.75, I'm going to multiply it by 4, except 2.75, 7.25, and I'm going to multiply that by 4, and when I do so, I get 29, and what's my label going to be? Quarters. $29 quarters. Now, we're running out of time. I want you to do, well, there we go. That's how we do this one. Look. I want you to do this for your homework. So go ahead and write this down. This is your only homework problem for tomorrow. Once you get that done, you got no homework for tomorrow.